Okay, in this problem, we want to evaluate the double integral of f parentheses x comma y is equal to x over the given region. So we're saying x would include 0 and pi, and y would include 0 and sine x. And this is our double integral. So let's get started. So the first thing we're going to do is write out our double integral. And we will write, x and y. So we're changing dA. So we can say that 0 pi and 0 sine x in terms of x, in terms of dy dx. Y is on the inside and dx is on the outside. And the reason we're choosing dy over dx, if, say for example, we chose dx over dy, that means sine x would be here. And on the last step, we would be inserting sine x. So our final answer would be like we would have x in our final answer. But doing it this way, our final answer would be an actual number. I mean, you can even try, if you want on your free time, you can even try 0 sine x, 0 pi dx dy, and what you're gonna notice is your answer would have like a sine x, and that's not what we want. We want an actual answer. So let's do it. So the first thing we're going to do is take the integral in terms of dy, and by doing that we would get x times y. This integral still remains, so we'd have 0 pi, and we would plug in 0 and sine x. So 0 sine x, this would be in terms of dx. And now we're essentially plugging in sine x and 0 in for y. And so what we're going to get is the integral from 0 to pi for x times sine x dx. And we don't have to worry about 0. If we plugged in 0, it would have been 0. And now we need to take the integral of this. But this isn't obvious. So we would have to use integration by parts or the tabular method. We used tabular method in the past, so we'll continue to do that. So let's do that. So we'll say tabular method. And so we'll draw a quick table. So it's tabular method alternates between positive, negative, positive. One of these terms, x or sine x, we take the derivative of. And the term that we're not taking the derivative, we take the integral. So we want a term that ultimately reaches 0 for the derivative. Sine x would continuously produce new terms, but x we would ultimately reach 0. So we have x, 1, 0. Sine x we would get sine x. The integral of sine x would be negative cosine x. And the integral of negative cosine x would be negative sine x. And what we need to do for this is we take the positive, we'd have a positive x, and we go diagonal. So x times negative sine x. Likewise, we have negative 1 now times negative sine x. So this integral would be equal negative x cosine x minus minus, so positive sine x. And our lower bound is 0, and our upper bound is pi. And so now we're plugging in x for these pi and 0. So we would get negative pi cosine pi plus sine pi minus 0. So 0 for x would make 0, and sine 0 is also 0. And cosine pi is negative 1. Sine pi is 0. So negative pi times negative 1. So our final answer is pi. And quickly, and this is our final answer. Quickly, I'm going to explain again why we couldn't have done 0 sine x, 0 pi dx dy. Because if you notice, in this final step, we're putting in actual values, pi and 0. Had we done it the other way, we would be putting sine x in. So our answer, we wouldn't have a physical answer. And that's why we arrange it like this. And that's all we need to do.